All right, let's go ahead and get started. Let me turn my webcam on for just a second to say hello. My name is Marcus with MLC CAD Systems, and today we're going to talk about what's new in Mastercam 2024. Specifically, we're going to go through the top 10 enhancements that are going to be the most consequential for you. The ones that you're going to notice immediately, you're going to be able to put to use to save time, make better products, all that kind of good stuff. And we'll start out with probably the most obvious one, and that is the GView Cube. So what that does is it just puts a cube at the bottom left corner of your graphics area that kind of shows you where you're at. So I've opened up a part here that has everything labeled the same way as that. So top, front, left on my part is the same as it is in the graphics cube. Now that cube isn't just about telling you where you are, it also helps you align things. So if you want to look at a face, like let's say I want to view the top or the front, just click that face. And there we go. The front face takes me to the front view. Left face takes me to the left view. And these are the standard view commands. There's a couple that you can't do that are standard. So hit click an edge. That's a kind of a 45 between two faces. And the corner is an isometric. If you want to pan, there's some little buttons here to pan. And then there's a flip 180 button, which is pretty slick. So there's the top. Boom. One click takes me to the bottom. Back to the top. Just kind of quickly look around and see what's going on. There's some other ways to modify that with Shift, Control, Alt, all that kind of stuff. You kind of hover over that and it'll show you, but it doesn't stop you from using, let's say, a space mouse or your mouse or anything like that. It's just another way to get there. Now, these views are changing the graphics view, so if your follow rules are set, if you execute the right view command on the GView Cube, the construction plane and the tool plane follow along. So if we turn off those follow rules, right, this isn't new functionality, but if I turn off those follow rules, now those will stay put and only the graphics view is being adjusted. Now, there's one more thing here that's important to understand is right now my WCS is the top of the part. So the top of the part is the top as it was imported, is the top view, everything's top, right, it lines up. But what if my part came in a weird orientation? My WCS needs to be on the right plane. Now, the top of my part is actually the right side. So if I click on top or if I use the top command for the view, it's going to take me to the top of my WCS. And now you can see the view cube and my part are no longer oriented the same. That's because it's way less important for you to understand how it was imported, right, and what orientation it was brought in. It's much more important to understand in what direction you're programming. So keep that change in mind. That affects kind of the WCS relative to the coordinate system and the GView Cube at the bottom left. But I think it'll be a lot more intuitive for everybody. The next enhancement we'll take a look at is about making holes, and specifically the graphical planes. So if you go in and you specify a drill operation, when you go into the parameters, there are going to be now a whole bunch of planes showing you where all those retract options are in your linking parameters dialog. Now, we've trained some classes already on 2024. New students are really loving this, but you can turn those off. If you're like, man, I've been doing this long enough, I know what everything it does, I don't need those displayed, just get rid of them. Incremental gives you a whole bunch of individual small planes, but if you change it to an absolute, like this clearance plane, that's going to give you one big plane. So it's a lot easier to see the difference between absolute and incremental and how that's going to be treated depending on where each of those holes is located on your part. In this case, if I want to make any changes to any of them individually, I can just go in there and drag one of those around, or if you want to just verify that you've got tip comp with breakthrough turned on, just check and make sure that plane is there. So like I said, it's going to really help people learn and understand what's going on in those linking parameters dialog. So if you've been doing this a long time, you don't need to see all that noise. Just turn that off and get right back to work. The stock model verify functionality has changed. I'm going to address that it's been put in the machine group setup dialog, the stock override. I'll address that in a little bit. But specifically, when you go to verify against a stock model, there's a new workflow. So in the past, let's say you grab this finishing toolpath, it's about halfway down my part, and I just immediately click verify. It's going to verify against my original stock definition. So the way you would normally fix that is you'd go into your simulation options and you do a stock override. You just say, when you verify or when you simulate, go ahead and use this other stock model or this 3D model to verify against. But I don't want to have to do that every time I want to go verify. So I'm going to show you a trick. I've got a stock model that I want to use in my tree, and so I'm going to go click it. Then I'm going to Shift or Control select the toolpaths I want to verify against that stock model. In this case, it's a whole list of them, so I'll Shift select from 11 to 17, and when I go into the verify command, what you'll see is it automatically overrides the stock with the one that I selected instead of the one that's in the simulator options. And then I can come in here and just verify right against that, very quick and easy. So if you're using stock models to run intermediate stock verification, go ahead and just create those and leave those in there. You'll be able to quickly utilize those, kind of refer back to them as needed to verify your operations without having to go through the entire verification process from the very beginning initial stock. So that's a big time saver. Let's jump into some lathe. So I want to take a look at turret-mounted angled milling heads. So here I've got a couple of parts that are lathe parts with live tooling, but you would need one of these angled heads to be able to finish it off with these chamfers. And so with that, in 2024, we can simply define those and use those as needed. So I've got this hex face on the end here, and I want to chamfer the corners. So I'm going to go in and create a toolpath. Now, in this case, it matters what kind of toolpath. I'm going to use a facing toolpath because a facing has a vector, kind of a normal vector, that's going to automate the orientation of this. If I was to use a contour, I'd have to go in and manually specify the 45-degree angle on that head. Here's my 1/4-inch flat end mill. That's what I want to use, but I want to put it into the angled milling head. So just right-click on that tool and say Get Angled Head. That Get Angled Head option brings you the Tool Setup Manager and just allows you to kind of specify where you want to put it, how you want those tools located or in what kind of holder you want them in there. So I've got everything over there on the upper turret that's specified so far. I've got some live tooling. I'm going to grab an additional one. This is the angled milling head, and I'll just drag that from the library to my turret exactly where I want it to be located. And if you hover over it, it's showing you kind of that option, all the information of where it can go. But we'll drop it on index 7, and then we'll go grab that 1/4-inch flat end mill and put it into the angled milling head, and now we're ready to roll with that. Now the dialog looks a little different. The icon shows you that right angle head that thing is in, so you can cut differently with it. Now if I was to select a normal tool, all right, I'm going to grab this 3/8 flat end mill, and I go into my cut parameters or my setup, you'll see that I don't have any other options than what I'm normally used to, right? Whether you're facing, making a slot, something like that, the setup dialog doesn't look any different. So what I'm going to do is grab that now angled milling head, and when I go into my setup, there's one additional operation called plane rotation. And that's just going to be the type of mill that we'll use to cut these faces. For the parameters on this facing operation, we'll do just a one pass, right? Nothing fancy. Just go ahead and tell it what angle to set the tool at relative to the cut and how much stock to leave. And we'll click OK. Now, I didn't have to set the angle of the actual tool holder because the facing toolpath has that built in. So it did come in at a 45, gave us exactly what we wanted, very quick and easy. We'll do a transform. We're just going to say we want to rotate this and apply that same facing toolpath 5 more times at an angle of 60 degrees each. And that should get us exactly what we need all the way around. So we're really increasing the capabilities of your lathe if you don't have a C-axis. Just index that guy and be able to cut these parts as needed. Let's do another one. This one's process hole. And what this refers to is drilling holes in your part based on the solid definition. So let's talk about that. If you've got a part like this one where it was imported as just a dumb solid, you can come in and click Find Holes. And what Mastercam does is it just says, go identify any holes and then basically replace them with hole features. It's as if you were drilling a hole yourself. And so now I've got all these features defined in here as these holes, and it defined or identified the depth, the diameter, all that kind of good stuff. And what I want to do is go in and drill these in the way that I normally drill a hole of that size. So we're going to use a new toolpath called Process Hole. So Process Hole takes the definition and runs with it. And in this case, the definition on those holes, because they're through holes, it thought maybe you wanted to drill them from the bottom. And I don't. So that's okay. I'm going to go fix that. There's some new enhancements in the solid hole geometry that helps you to make the process hole even more powerful. So an example, in this case, I'm going to go find my simple through holes and edit the parameters. And there's a new option, real easy and basic, just says flip direction. And it's going to reverse the direction that it drills those holes, so I can define them from the top. Any other information you need to change, if you change it here, it's going to change it in the process hole, because the changes here are driving what that's going to be. So if the part comes in with an odd size that's not a round drill number or anything like that, or maybe they put a note in there that said chamfer these edges, but they didn't actually give you the geometry, you can go in and modify that here and actually get the geometry to look exactly the way you want to cut it, not just the way the 3D model happened to be if they didn't quite give you a clean model. So those holes are now perfect. It's exactly the size I want. What I'm going to do now is go in and run the process hole command. And it's nothing in here so far, right? No tools, no tool paths, no nothing. When I go in and grab that series of holes, it brings in all the holes. I can adjust the sorting if needed, but everything's looking good really here as far as that. The process is coming from a process library. We'll see what that does, but effectively, whatever the solid geometry feature said that hole needed to do, and whatever the process parameters says we do with holes like that, that's what's going to get done. So I've got a 3/4 inch spot drill, and then I'm just using a peck drill to finish cutting these all the way through. And any other options that I've set in my process parameters file are going to get reused. And you're basically just kind of drilling a whole bunch of holes in a standard file and then saving that out. And you can go modify that and say, every time I drill this hole, let's increase or decrease the peck distance or depth a little bit to work a little bit faster or better. I'm going to modify that 3/4 inch spot drill because that one I want to make it tool number 1. I also want to show you kind of how these process parameters work currently. So I'm going to grab another set of holes. These are the 5-axis holes that are all kind of along these edges here. So when I execute the process holes command and go grab it, you're going to find that it does not grab all the various holes because it's grabbing them based on their definitions. So if I go ahead there and grab each one, they're defined separately because they all have different planes. They're all cut in a different orientation, but it doesn't need to be one solid feature for you to include it in one process holes command. So notice it's grabbing and identifying all the various different types of holes. I can now go into the process parameters. This one I'm going to grab a different library here, and I can kind of pick that up and make sure that it's going to bring in the parameters I want. Now these toolpaths are kind of involved or included in this process hole toolpath. You can still edit them directly, just like you normally would if they were standalone. This one's trying to bring in another 3/4 inch spot drill. I'll say, hey man, I've already got one. Don't bring in another one, just let me use it. All right, so it's kind of throwing up some errors and some messages to kind of help us out. For the peck drill, same thing. Everything's there. It identified it as a 5-axis output because of the way the holes are all oriented relative to each other. So let's click OK and take a look at it. Now my default retract probably didn't get me exactly what I wanted, so instead of trying to adjust that there, I'm just going to add a quick safety zone. And for this one, because we're doing a 5-axis, it does a nice job of doing a spherical safety zone, kind of around the part. and then that gives me a nice, safe retract distance and cleans up those transitions between the holes. All right, feeling good here, so let me go ahead and regenerate that and backplot it to see what this does. Just like we saw before, we've got the spot drill, and then we go through and peck the rest of those holes. But notice it didn't spot all the holes, right? It did the spot, it changed to the drill, and then it's going to change back to the spot and then go drill the other holes. Right, so because process hole combines these various different sub-features into one toolpath, it's going to make it harder to sort those, but that's okay. What you can do is just, once you've got everything set, just right-click and explode process hole, and that takes those process groupings and separates them out. And then you can go in and say, let me sort by tool number. Boom, all my spot drills are being done first, and then it's minimizing my tool changes after that. So process hole is pretty slick for automating standard types of holes to the specific way you want them to be cut. Let's take a look at mill turn. So with mill turn, we're going to be able to create a lot more complex geometry, and in a lot of cases do it with a lot fewer tool changes. So this part, I'm going to do two major operations on it. I want to basically finish the outside and finish the inside. So we'll do a section view and take a look at the first toolpath I've got set up here. So a B-axis toolpath will rotate the tool as needed to clear and reach anywhere it needs to reach. So for this one, it's set up as an automatic. We'll just backplot it and see where we're at and what we may need to do to it. So far so good. It's approaching from the outside, from the right side, but then it sort of plunges in. It does rotate nicely around and cut everything pretty well, but I've got a few changes I need to make. So the first thing I want to do is, if you notice, it kind of plunged down from above into the material. I want to change where the start point of that is. And we're using stock recognition, so it sees where the stock is. All I have to do is go in there and modify that, and I can go and move it to wherever else on my stock I want. I can even kind of move it out further to get all the geometry involved that I need. So now it should approach in a different way because it's going to start from a different location. The other thing I want to do is rechain this. So with the chaining, all I'm doing is extending it out to include this face groove. Normally that would be a separate toolpath entirely, right? In fact, this might be several different toolpaths to get all this geometry. It might be some tool changes as well. But by coming in here and chaining this all in one B-axis finishing pass, I can really save a lot of time. And this will come in here and take care of this whole front and outside. Last thing I want to do is adjust where I can cut on the insert. Now, you can go in and you can say, hey, don't let the insert go past a certain depth. But I don't care about the depth. I just want to make sure it only cuts on the front edge. So you can now manually specify where on the cutter you are allowed to cut. So instead of saying, okay, don't go past this depth, just say don't cut on the backside. Make sure, because this will basically completely eliminate plunging. This will say, hey, don't ever cut back on the back end, rotate as needed to maintain cutting on the front face, which is where I'm intending this to be. So we've got 3 changes made. Let's see how this approaches it. The first thing it's going to do is it should come in at a completely different location and cut further down on the chain, maintaining a nice angle all the way through and only cutting on the front side of that cutter. Let's take a look, and you'll notice it's rotating to try to bias itself towards cutting just on that front face. So we may want to clean that up a little bit more, but that's looking really, really good for us. Let's go ahead and jump to the inside, the ID, and we'll do that one as well. And for this one, I know I'm going to have quite a bit of rotation involved. In 2023, Mastercam 2023, they introduced the manual tool axis control, where you can create a bunch of individual vectors, define exactly where you want the axis of each of these pieces, each of these segments to be relative to the tool. With the 2024 release, we have a modified version that really simplifies and streamlines it. See these vectors? Grab one of those and drag it around, and you're going to see an outline of the tool. So it's a lot more obvious for some of these tools that are, kind of a different angle of the insert coming off. It may not be intuitive what that vector is representing. This will get you the ability to adjust it quickly. Let's backplot the original one. I canceled out those changes, and we'll go ahead and play this and just see where we're at so far. We shouldn't have any interferences, but as we come around here, look at this. It's practically cutting with the tool holder, and we definitely don't want that full engagement on that insert like that. So let's go in and adjust the tool axis control, and we're going to use that modified approach to kind of start from the automatic, make only the changes needed in the areas we need to, and then let the rest of it take over. So in our modified, we checked this earlier, right? We'll grab this one and rotate this around, give it a round number like 55 is fine. For this, it isn't really going to matter because it's adjusting curvature all the way around. But then as it goes around this horn, you've got kind of two very far apart vectors. So I'm going to put a vector in the middle. To do that, double click that line, and now you can drag that vector anywhere you want to get it to kind of be, give the approach that you need. For this one, it shows red, right? Highlights very solid red everywhere you have a problem if you run into any interferences, but everything's looking pretty good on this guy. So we'll go ahead and finish that out, click OK, and regenerate the toolpath and verify it. Hopefully, we didn't even explore further down into that part, but because we're using the modified, it should just be defaulting to the automatic approach. It's going to do a nice job of cleaning that up for us. All right, so here we go. We'll see what we got. We should be coming in with the same approach as we did before, but then we should pretty quickly rotate around. Then we get that rotation at the end, and then the automatic takes back over. We get a nice clearance to the holder. We've got a really tight retract here, right? You might want to increase, give that a little bit more clearance to decrease the pucker factor on that one, but that's going to really simplify things. And you'll notice with two toolpaths, we were able to finish all the faces on this very quickly and easily. For dynamic trim, the big enhancement here is just a change in the way the dialogues are laid out. So I'm going to go ahead and draw out just a really basic profile as just an example to show you what this looks like with the new trimming capabilities. So if you look up in the modify dialog or the modify area, you've got the dynamic trim command. And dynamic trim, it basically just combines all the other different types of trimming into one dialog. So you can trim or break, you can use automatic, you can divide, trim to point, whatever you've got, you can go in there and look at it. You hover over any one of those and it shows you a nice tooltip with a graphic to show, okay, if you click like this and then like this is what you're going to get. So that way if you've forgotten how to do your trimming from your essentials class or anything like that, you could kind of go in here and relearn. I'm not going to go through the full trimming tutorial, but we will put this up on website so that you can see and remember all the different approaches, including that pesky trim 3 entities. If you don't do it a lot, that one can kind of throw you. So we'll jump into some multi-axis now. With multi-axis toolpath, we've consolidated that in 2023. And unified multi-axis toolpath will give you multiple different approaches possible within one toolpath dialog. By giving you color display, it's going to make it easier to understand what's going on at a glance as you create these potentially complex toolpaths. So I've got 2 to create here. One, I'm going to do the floor on this face right here, but we'll start out with this guy, and we're just going to modify the toolpath. Those dark blue lines, those are wireframe entities. They were just turned dark blue for reference. But when you go into the dialog, anything that's been selected for that toolpath in the cut pattern now has that color-coded display. So looking at the colors, you can see my curves are light blue. You know, you want to change them to red or something like that, you can. You can even change each one individually so you know which one's the start, which one's the end. My cut machine surfaces are the green. But let's say that I've got this in here and I'm thinking, okay, I don't like this approach. I'd like to cut it the other direction. To do that, I'll just clear out these curves and say I'm not going to curve based on the solid geometry. I'm going to curve based on the top and bottom edges, and that's what that wireframe geometry is for. And the only reason I did it as wireframe is because I wanted to show you that anything that's been selected in the dialog will get their color changed. Anything that's not will maintain the color we've specified it normally. So it's only in the dialog that you see these various different colors. So it's clear what has been selected, what needs to be reselected, or what's maintained its selection, even though I've changed my strategy completely. We're off to the races. Let's do this one more time over on that other face. We're going to just kind of finish the floor of this area. And for this one, we need to add some avoidance geometry. Because right now it looks like we're probably going to start cutting into those faces. So we're going to go into the collision control and just say, make sure that the tool itself avoids these various faces. And we'll go grab those, the purple faces. This geometry was a bit problematic. These faces weren't exactly tangent everywhere. So we had to kind of go in and grab them manually. Otherwise, I would have just grabbed tangency. Use my GView Cube to go isometric. And now you can see very clearly where my boundary is, my cutting geometry, and my avoidance regions. So I know I've got it done. And this is behaving just like those high-speed toolpaths already do. Should make everything a lot more consistent and easy to understand. All right, Save Load Defaults is a new feature that allows you to quickly recall settings for your various toolpaths. And so for this part, I want to remove a whole lot of material really quickly. And I've got a cutter that I like to use, and I've got all the settings already there for it. So we'll just define where we want to cut. This is real simple, just from outside. We'll avoid those feet, and we'll cut down to kind of that next surface. And with this one, I just created a brand new one. I didn't import a toolpath with my settings in it. I created a brand new blank toolpath. And so this toolpath doesn't have, for example, corner pretreatment turned on. My depth of cuts is disabled. I don't have my arc filter enabled, right? The stock to leave isn't where I like it. Nothing is where I want it. And that's why normally I would have gone through and imported, right, an existing toolpath. So I don't have to sit there and go and change each of those dialogues independently. So let's go ahead and load from a file the parameters that I'd prefer to have. And I'll just do this drop down under toolpath defaults, and I've only got one right now, but it's a dynamic with a 0.4 step down. Everything's the way I like it. The stock to leave is there, my step over, my step down, corner pre-treatment has been turned on, depth of cuts is turned on. I've got my arc filter the way I like it for roughing toolpaths so that it plays well with my control. You know, everything's right where I want it. So again, you can import an existing toolpath and rechain it, but this way you can quickly grab that, even apply it to an existing toolpath. If you want to make changes to it, let's say I want to change this from absolute to incremental, and I want to save that as a new default option. All I have to do is click the Save button, and it saves it to that operations library. Right? Make sure you give everything a good name so you can understand what each one is, but it's a great way to save all your data and really eliminate a lot of that extra time kind of poking around in your dialogues. Change those settings manually whenever you're trying to dial something in or run something new. But once you get it working the way you like it, save that out and reuse it so you save yourself some time. The machine group setup dialog is the number 10 enhancement. And basically it just consolidates a whole lot of information, a whole lot of other dialogues into one, making it a lot easier to see where everything's at, and especially to get things started at the beginning of your project. So we'll start out by going into our project options, and it takes us right into the machine group setup, which is where you'll find a whole lot of different types of definitions. So if you find yourself expecting another dialogue and you end up here, it's because it's been incorporated into this dialogue. Machine definition and the post processor and everything's looking good in the machine itself. For the master model, this is where I'm just going to go in and grab it from the geometry that I've imported to cut on. I can go change any colors or anything else I want about it. For the stock, I can come in and define the stock if I haven't already. Right? Grab a couple points, maybe do a best fit on a rectangular block. But for this one, I have already created a 3D model for that stock geometry. In fact, I used it to define the location of these various vices. So we'll just go grab that one and specify it. And you'll see it just kind of speeds things up if you've done some of that pre-work ahead of time. The stock volume, and if its density is set, the weight is displayed there so you know kind of what you're getting into. For the fixtures, you can add those graphically, or I've got them on a level again, so it just saves me a little bit of time. Everything's looking good here, and you just kind of go down the line and say, okay, you know, I can address this later, but I just want to check and make sure everything is where I expect it now. I got my tool crib all set up. As I add additional tools, those will obviously change, but I got to preload that if needed. Change how the tool numbers are assigned, what kind of defaults I want to use, etc. The last one I want to look at is the simulator options. And so this is where normally you would go in and specify what stock you want to verify against. In this case, I'm going to specify my machine for the simulation, but there's that stock override. I don't have to go in and change the stock setup anymore. I can just go ahead and grab that stock model and verify against it. But for those of you that have been using the machine group setup dialog in 2023, in 2024 now, it's just completely there. Everything's working exactly the way expected. You're not going to have multiple places to go define anything. It's working really, really well for us so far. But what's a top 10 list if it doesn't go to 11? So I've got one more for you. This is a Waterline toolpath, and I just want to show you two really simple and easy enhancements on this one. So the part that I'm cutting, right, I've gone ahead and created a stock model. I roughed it out, created a stock for the op 1. I then flipped it over, machined the other side. That's op 2 or side 2 with another stock model. And everything's going pretty well, pretty basic, setup. The Waterline toolpath, the way it works is it creates even step downs that just kind of trims the perimeter of the part, which works much better on vertical or nearly vertical faces than it does on really shallow faces. So this is the Waterline toolpath that I've created so far, and there's two things that I don't like about it. The first one, if you look along those shallow faces along the top, see how wide that step over is? It's a consistent step down, but it's a really wide step over, which it really isn't helping our surface finish. And then there's a bunch of wasted motion at the bottom. After it's finished cutting all the stock, it just keeps going to the original stock depth. So in this case, I'm going to go ahead and modify this Waterline toolpath. And the changes I want to apply are two really simple ones. The first one, detect stock breakthrough. Really simple, does exactly what it sounds like. It just understands once the stock has been cleaned up in that area, and it just stops cutting there. The second one is for the step downs, you're going to be able to allow partial cuts. So these cuts, right, you have a consistent step down unless it's a shallow face, in which case the step over is bigger than the step down. In that scenario, allow another cut to come in and just clean up that area. Let's see what this looks like. First thing we'll look at is the top of the part. You see those little short single passes, or in some cases it even does a double pass. So in between each of those very small step downs, it does additional passes, cleaning up those scallops and giving us a better finish only in the areas that are shallow, so you don't have to really ramp down the step down globally and take a lot of extra time. And the other one is all the material below the part has been removed. So once it stops cutting anything, it refuses to cut air and just finishes up the toolpath. So it's going to save you a lot of time. This one will actually run faster and give you a better result with just 2 checkboxes enabled. So I hope you really enjoyed Mastercam 2024. I invite you guys to keep in touch. Reach out to us anytime. We're available on any social media platform. Obviously, our website, mlc-cad.com. You can subscribe to our YouTube channel. This video is going to be on our YouTube channel pretty quickly, so definitely reach out there. Let me know what kinds of questions you have, but let's open it up for a Q&A and see what everybody thought, see if you guys have any questions.